Alright guys, this is our last video, and just to show you that there is still life, here's Luna. Say hi, Luna. Yeah, she's the little instigator. The big one doesn't like to be played with, and she sort of forces play with the big one, and the big one just wants to be left alone, and the big one is also extremely vocal. So all that screaming you heard, that wasn't Luna. That was the big one. Okay, which is also, she's alive. She's just hiding under a bed right now because she's super ticked off at the world. So we will end by introducing reaction mechanisms, and then we'll talk more about it next class. But do you remember a couple of lectures ago when we talked about rate laws, and I told you that rate laws, you cannot assume that the coefficient is the exponent. You have to determine that experimentally. And then we further drove that home by telling you guys that, yeah, that's how you have to do it, because we're going to make you do it that way in lab, right? Well, that's because all a balanced chemical equation does is tell you what you start with and what you end with. It doesn't tell you how the reaction is occurring. And the problem is, a lot of the reactions we look at in chemistry are actually mechanisms, meaning they're multi-step processes. And these multi-step processes are not represented in an overall balanced chemical equation. You have to look at a mechanism, okay? Because the mechanism explains how bonds are broken, how we get these sort of intermediate compounds that may be formed, and none of this appears. Intermediates, none of these things appear in the final balanced chemical equation, okay? So basically, the problem is you can't assume that the reaction you're looking at is an elementary reaction. If it is an elementary reaction, then the coefficients are the exponents. And if it's an elementary, that means it occurs in a singular step. But you don't know that. And since we don't know that, we never make the assumption that the exponents, or that the coefficients are the exponents, unless, now that I've told you what an elementary reaction is, if I tell you that something is elementary, you could write me the rate law for it, because you would just use the coefficients as exponents, okay? But we're going to go into reaction mechanisms and all this stuff in a lot more detail in the next class's lecture, which will be the videos on Friday. So the primary reason for this video was to sort of introduce the next lecture, to show you proof of life for the cats, because I figured you might want to see it after the fight that you heard, and to also encourage you guys to use that discussion board, okay? There is a discussion in the assignments place. Please, please, please use that discussion, okay? The purpose of that is to allow for you guys to talk amongst each other. It's my only way that I have to generate a classroom environment. We have been banned from using any live anything other than live text. Okay, so this is our only option to do this. They have sort of poo-pooed on all my other ideas. Okay, so this is what we got. Let's use it. And this way I can address the same question once instead of 14 different times in 14 separate emails. Okay, so you're also helping me because with the workload, and you're allowing us to recreate the classroom. Okay, so if you have any questions, there is a discussion specifically designed for this. Please use that discussion to discuss the lecture, okay, with me and each other. Remember, I will be live in that discussion from 1 to 3 p.m. tomorrow. Now, recognize I'm live in all my discussions from 1 to 3 p.m., so I may not give you an answer within 30 seconds, but you will get an answer in a very short time frame. And then also feel free to post in those discussions outside of those times. Just know that it may take me a little bit longer to get to it because I'm not necessarily planning on being right there. Okay? All right. So that's it. Happy studying. Please reach out if you have questions. All right. Stover out.